Today we're going to start solving Nebula exercises or Nebula exploit exercises. So basically you can download Nebula from this page, this link. It is an ISO file, and then you can just import it into your VMware workstation. Nebula is a great resource or a great virtual machine if you're just getting started in learning Linux privilege escalation, or in general to enhance your Linux knowledge. In this video, we're going to solve as much as we can, starting from level 00, and hopefully we're going to end all these levels in one video. If we don't, then we're gonna continue the rest in another video. All right, so let's get started. As you can see, guys, I have imported the ISO here in my VMware, and on the other side I have my attacker machine where I have two tabs opened. One is for Nebula, where I'm gonna log in to the virtual machine. Another one is a local listener in case we needed to get a reverse shell. Let's go over the description. This level requires you to find a set user ID program that will run as the flag 00 account. You could also find this by carefully looking in top level directories, as in / for suspicious looking directories. Alternatively, look at the find main page. To access this level, start by logging in as level 00 with the password of level 00. So let's go ahead and do that. So in my Nebula tab, SSH level, we're gonna put this here and just modify the username level 00. The password for level 00 is the same as the user, level 00. Now we're logged in as level 00. So the task description states that we need to find the set user ID program, or a binary that has the SUID bit set. Obviously, we're going to find a lot of them. But the remark of this program, or the binary we need to focus on, is that it has the flag 00 account as the user, or as the owner of the binary. So to do that, we're going to use one command, which is find command, followed by the directory that we will be looking in. So it's going to be the full file system indicated by the /. And then to find the SUID bit programs or binaries, or the binaries that have the SUID bit set, we're going to use -perm -u equal s. We're looking for this bit, the s. If this bit is set as part of the permissions of the binary, then this means that the binary has the SUID bit set. And then -type f, indicating we're looking for the type of binary we're looking for is file, and then we're going to pipe this into dev null to ignore the errors. So as expected, we have a lot of binaries with the SUID bit set, but we're looking for the binary that has a flag 00 on it. So obviously it is this binary. We're going to navigate to the directory storing the binary. So cd ls-la, and as you can see, we have this binary. Take a look at the permissions. As you can see, we have the s bit set on the binary, which means the binary here can execute as its owner. So the owner here is a flag 00, and the group is level 00, which means level 00, anyone who is part of this group can read or execute the binary. So we're gonna go ahead and execute the binary flag 00, and then as you can see, the first challenge is solved. Congrats, now run the get flag to get your flag. Throughout all of the levels, you need to, every time you solve a challenge, you need to execute the get flag to confirm that you have solved the challenge. So get flag, and now we have successfully solved the challenge. So what we did here, we just found a binary that has the SUID bit set, okay, and we executed the binary as its owner. Every binary that has the SUID bit set can execute as the owner. Although we are not flag 00 user, rather we are level 00, but because it had the SUID bit set, we were able to execute the binary as flag 00. So kind of we have successfully impersonated the context of this application execution as the user flag 00 by virtue of the SUID bit set. So that's it for level 00. Level 01, we're gonna log into level 01, or we're gonna just change the user level 01. The password is level 01, and now we're logged in as level 01. No, level 01, level 01. Okay, so we logged in as level 01. So we're gonna navigate to cd home flag 01 and take a look at the contents. So we have, okay, before we do this, let's go to the description. There is a vulnerability in the below program that allows arbitrary programs to be executed. Can you find it? To do this level, log in as the level 001 account with the password level 01. Files for this level can be found at home flag 01. So we cd to the directory stated in the instructions, and we can find that we have one binary named flag 01 where the owner is flag 01 and the group ownership belongs to level 01. So we can execute this binary because we are a part of this group, and the binary has the SUID bit set. So what happens if we execute this binary is going to execute as flag 01. So let's go ahead and do that, and we get this. And now what? We're given the source code. Let's go over the source code and see what happens. So this is program written in C, and we have this remarkable line. There is a system call, okay, to execute echo, and as you can see, echo is called by looking for the path in the environment variables. So when we execute /user/bin/environment, here we are instructing the system to execute the following binary by looking at the path of this binary in the environment variables, which is not a correct and secure method to execute binaries. The correct way to execute binaries, such as echo, is by defining the absolute path, the full path to the binary, rather than letting the system define or find the path by looking in the environment variables. So how we're going to exploit this? We're going to create our own version of echo. Okay, if we create our own version of echo and put this version in a directory we control, and then we add that directory to the environment variable, we can then call our version of echo using the precedency of its path. Let's go ahead and do this. The first thing, we're gonna go to temp. See here, guys, we have echo, which I created. Cat echo. Well, it's a binary. Under the temp directory, we can see there is the echo that I created. So as you can see, guys, the echo binary that I created is actually a symbolic link to the get flag executable, which we need to execute to solve every task. So if we execute echo, it's going to execute get flag. But since echo binary that I created actually is owned by level 01, when we execute echo, it's going to execute get flag as level 01, which we don't want. We want echo to be executed as flag 01. So how I created the symbolic link, just use ln-s and then bin get flag and then echo. Okay, you can just use another version, echo v2 ls-la. As you can see, another binary or the symbolic link was created. Let's do the solution over this version, version 2. So now we have created our own version of echo. Let's remove the old version and then move echo 2 into echo. Move echo 2 v2 into echo. So why I'm doing this, because we need the binary name that we created to match the original name in the code. We are creating our own version of echo. That's our own version now. It's a symbolic link to the flag or the binary that will solve the challenge. That's the executable file we want to call using the system call function. The next thing we want to do, we are at the temp directory. We can add this directory to the environment variable. Let's go ahead and echo the current value of the environment variable. So this is the value of the path environment variable. So when the code runs here, it's going to execute echo by first looking through the environment variable, meaning it's going to go over these paths. Okay, it's going to start with user local sbin. If it finds echo, it's going to execute it. If it doesn't find echo here, it's going to jump to the next path in line under bin directory. And it's going to keep doing this until it finds the echo binary here in one of these paths. So the execution precedency here starts with it's actually based on order. So we start the first one, followed by the next one, up until the last one. Now, if we add the directory we are at, which is temp here, we can add this to the environment variable path. To do that, we're gonna say export or path equal temp. This is the directory we want, and then followed by path. So now we echo path, and now the directory we are at has been added as the first one in line. Next, now when the code here is running, or when the code is run, it's going to again to look for echo in the environment variables. Luckily for us, we have created our own version of echo whose name matches the original name in the code. Hence, when the code is run here, it's going to execute our own version because it does exist in the first directory we control. To prove this, we're going to home flag 01, or we're going to execute flag 01. When we execute flag 01, it's going to execute this code, which in turn is going to call the system or perform system call to execute echo from the environment variable, which in turn execute our own version of echo to solve the challenge flag, solve the challenge. As you can see, we have successfully executed get flag on a target account, which marks the end of this level. Let's go to the level 02 now. So we change the user to level 02, level 02, and now we're at 02. We're gonna go to cd home flag 02. Okay, we have a similar file here. Let's go through the description. There is a vulnerability in the program below that allows arbitrary programs to be executed. So we're facing something similar to the previous level. So we go over the code here. This code represents the flag 02 binary here. Now we have these three remarkable lines. The first one uses ASPrintf. And in the ASPrintf, there is a use of the function get environment. Now the get environment will find the value of this environment variable in the system. And when it finds the value, it's going to store the value in the buffer here. Okay. And then in the printf, it's going to print this about to call system, and whatever is stored inside the buffer will be printed out. And then it's going to perform system call to execute whatever inside the buffer. So if we control the value of the environment variable user, we'll be able to control this entire execution flow. Obviously, we want to execute again the function or the binary get flag. So this one, I guess. Yeah, so we want to execute this. To do that, we want the code to do this for us. Okay, so we want to replace the value of this environment variable with get flag. Let's take a look at the current environment, or the current value stored in this environment variable user. So the user is level 02, which is the current user we are logged on with. So basically that's the value here. Now if you go ahead and execute flag 02, as expected, as you can see, about to call system / min echo, and level 02 was printed out, and then level 02 is cool, just as we explained here. Whatever value stored inside the user and therefore inside the buffer will be printed out in place of the string here. All right, so what if we change this, okay, to the bin get flag, right? What's gonna happen? Assumingly it's going to execute get flag. However, it's not gonna do that because here it is interpreted as a string. So to be able to do that, we need to use command chaining, meaning the first thing we want to do is to change the value of the environment variable user. To do that, we're gonna say export user, okay, and then here we put the value we want. All right, so command chaining is when you chain multiple commands together and then they will be executed followed by one another. The separation between these commands will be the semicolon. So if I put something here like maybe echo, and then here I put ls, what's going to happen? It's going to execute echo and then ls. Let's go back to the code. So here we want to prevent get flag. Here, where is get flag? I mean the function. We want to prevent the function from being interpreted as a string. To do that, we're going to need to use the semicolon to end the printf command and start a new command. Okay, so here the first thing we're gonna do is first use semicolon. We want to end the printf command, and then we start a new command. Obviously it is the get flag, and then we use semicolon to followed by the whatever comes next. If we do that and then we execute flag 02, as you can see, guys, we have successfully executed get flag on a target system. Now if we change the value of user to only be get flag, it's gonna be interpreted as a string because now it is part of the printf command. Okay, so that's how to understand the command chaining in Linux. All right, level 03. So level 03, level 03. cd home flag 03. Okay, so we have two scripts here. Let's go over the description. Check the home directory of flag 03 and take a note of the files there. There is a cron tab that is called every couple of minutes. Okay, so we have a cron tab. A cron tab is a tab that includes all of the scheduled tasks in Linux, similar to the scheduled tasks in Windows. So we have two scripts here, or one script, Writeup, and we have here directory. Let's take a look at the script. Probably this is the script that is executed regularly, or that's part of the cron job. So cat Writeup. Let's take a look at the script. So we have a for loop here. It's looping through the contents of the directory writable.d, and then it's executing whatever it finds inside of it. Later on, it removes the thing that executed. So if we put a script here inside Writable, it's going to be executed by the Writable bash script. So inside Writable directory, we create a script, okay, and then thanks to the cron job here, Writable.sh will execute the batch script we created earlier in writable.t directory as flag 03. Let's take a look at the writable.t directory. Okay, there is nothing in here. So here we have to, it's up to your imagination to create whatever you want, and it will be executed by the writable script. So my preference here is to use a listener or to get a reverse shell. So we already have a listener running here on port 45.5. What if we create a simple one-liner that connects back to my machine here? So echo, then we grab the reverse shell. Preferably we should have it as netcut reverse shell. Okay, this one will do the job. We place this inside double quotes. We change the IP and the port. In here, we put the IP address of my local machine, which happens to be this IP address. Okay. We send the contents into a script. We name it based on our preference. So it's going to be something like shell.sh. We give it permissions. And now we wait for the shell to come, or the reverse shell to come to my machine. If we take a look again at writable, you can see this is the script. Let's see here. We should receive the reverse shell soon, hopefully. Now, this reverse shell will be executed as flag 03 because the original script that is executing our reverse shell is writable, which holds or which has flag 03 as the owner. Now the cron job runs every 5 minutes, every 6 minutes, but eventually it will come here. Let's go to level 04. We're going to assume this is done. Level 04. This level requires you to read the token file, but the code restricts the files that can be read. Find a way to bypass it. So there is a token in this code here that we need to run, but there is something that prevents our user from reading the token. So look at the code here. We have the first if statement, where we have to supply the token to be read by the binary, and then we have another if statement that is checking on the token, and it will print out you may not access the token. Let's see here. Okay, and we got the shell ls bin get flag, and we are done with this one. Okay, exit. Start the listener again in case we needed it. Right, so level 04, so level 04, cd home flag 04 ls-la. We got the token here and the get flag. Let's go ahead and execute flag 04 and provide the token as a first argument. And as expected, we may not access the token. So there is a way to get around this. We need to read the token file, but obviously we don't have permissions to read it because we are not the user flag 04, which owns the token. So to do that, we need to find a way to direct this ownership to level 05 or level 04 user. To do that, we're going to use the power of symbolic links. cd to temp, And here we're going to create a symbolic link, ln-s home flag 04 token level 04, which I already did here. I created a symbolic link, okay, which highlights the token as the source file and the destination level 04. Now, if I provide level 04 as the argument for the flag 04 binary, it's going to access the contents of the token by virtue of the symbolic link. Let's go ahead and give this a try. cd home, and then flag 04 temp level 04, and now we got the contents of this token. Next step is to use this content, or to use the token value as the password for the user flag 04. Get flag, and we solve this level. Level 05. Check the flag 05 directory. You're looking for weak directory permissions. Okay, so su level 05. Su level 05. Alright, so now we cd to home. Okay, look at this. So we have one, ignore this one. Take a look at this one. Dot backup. cd dot backup. And we have one compressed file. But unfortunately, looks like we're not gonna be able to access or uncompress this file or extract the contents because we are not the owners of this file, nor we are part with the group ownership. So the only way to do this is to move this to a directory we control. As always, we move this to the temp directory. Back up, or we copy this, it's better, to temp. Okay, we got this file here. We're gonna now tar-zxvf. So now we got the content extracted under SSH. cd.sh, and now we have the public key and the private key here. So using the private key, we can now log in to flag 05. So you can just copy this ID RSA to home, maybe level 05 SSH, using the private key here, SSH flag 05 at localhost. You can now log in, but there is something wrong with my version of the virtual machine that is giving me this error all the time. But if you try this, you're going to be able to log in as flag 05 and execute the binary that will make you step up to the next level. Okay, level 06 is fairly easy. We get the hint from here that the target Unix system is a legacy Unix system, which means we're gonna find the hash of one of the users hard-coded in the password file. To verify this, we're gonna log into level 06 and execute cat etc password. Here we're gonna find the hash of flag 06 account. We're gonna copy this line and head over to my local machine where we have the file here. We have the line copied into this file. Then we execute John Derper on this file so that John recognizes the type of the hash and finds the corresponding password. I use /show because I have done this before. And now we can see that the password is hello. This will enable me to log into flag 06 and execute get flag to solve this level. Su flag 07. Wait a minute, I think we did a mistake here. Flag 06 credentials came from, what is the current ID? It's flag 06 get flag. Okay, yeah. So this solves this challenge. Now we're gonna go to level 07, change the user to SUID level 07. Okay, and then home flag 07. Okay, we have two files here. One is an index CGI, and another one is the web server configuration file. Let's read the description. Flag 07 user was writing the very first Perl program that allowed them to ping hosts to see if they were reachable from the web server. So this is the code here. Supposedly it is designed and coded to test the reachability of hosts. And if we read through the code here, guys, we can see this line that represents the core of this code. Ping-C3, we send 3 packets to the host. Now the host value is stored in the host variable. And as you can see, the host variable is directly used in the command without any input validation before calling the system command. So this is clearly a command injection. What we're going to do, we're going first to test this code. So we're gonna go here, execute index.cgi. Obviously it's gonna tell us the exact usage of the code. So usage ping, and we have to supply the host. This is the variable that stores the host value. So we're gonna say index CGI host, and I'm going to enter my IP address, my local attacker IP address, 125.128. I remember it was like this. Yeah, 28. Okay, we see 3 packets that got sent back from my machine, indicating that this is a live machine. All right, so now here, how to execute system commands and take the advantage of the fact that there is no input validation applied on the user input represented by the host variable. One of the ways is to use command chaining, and we have talked a lot about this. Command chaining is when I use semicolon or double ampersands, okay, between 2 commands to indicate I want to execute them both followed by one another. So here we go back. This is the user input, the IP address. I can put semicolon to chain it to, or to chain this into another command, and then I can use the desired command, ls. And now the output of the ls command should appear here. And indeed, guys, we have the output of the ping command and the output of the ls command, indicating by the directory listing of the files. Okay, now the next thing we want is to execute the get flag. But this will not work because now get flag will be executed using the level 07 user, which is not what we want. We want to execute get flag as a flag 07. So let's go back and display the current permissions we have. So index CGI is owned by root as user and the group. Same for the web server configuration file, which means if you want to execute get flag function as flag 07, we're gonna have to execute the script as a flag 07 or as the root account. Apparently there is no way to do this, but we have something left, which is checking the configuration file of the web server, cat t, and here we can see that the web server is running by the user flag 07, and it is listening on port 7007, which means if we let the web server call the index CGI script, we're going to be able to execute the command as the calling process. The calling process here is the web server process, which is operated by the flag 07 in exactly what we want. Now, how to call the script using the web server process? We're going to have to use one of the commands that actually calls the system, the web server process. We have curl, we have wget. The one installed on the machine is wget, so we can use wget. And then here the localhost IP address, followed by the port, and then we have index CGI the script, and then we supply the variable So here we can use 192.168, 125.128. Okay, followed by the command we want to execute. So basically I want to execute get flag, so I'm going to use dot, but I have to URL encode this, so it is 3b. This is the URL encoding of the dot. Instead of executing dot get flag, I want to represent the dot with this, and then I use get flag. Connection refused. Okay, so there is a bug in this challenge in that the web server dies after a couple minutes of starting the machine. So what we have to do, we have to go back and restart the machine. I'm going to shut down this machine and restart it again. Hopefully this will solve the problem. So we needed to call this, we need to use the execute the duplicate command from here. Gonna copy this. Cannot write to permission denied. Alright, so I'm going to remove this part. Try this. Again, we're getting permission denied. This is because maybe you're trying to save the file in flag07 account and without permissions or the appropriate permissions to save the file under this directory. It's gonna change this to temp and re-execute. By the way, guys, I made a mistake earlier in explaining that this is the URL representation of the dot. It is not, it is the URL encoding of the semicolon, this one. Okay, so here we use semicolon and then get flag. Let's try now, and we get the file now saved. ls, this is the file that got saved. If we cut this file, as you can see, guys, we got the output of the get flag. You have successfully executed the flag on a target account, and this wraps up this level. Okay, level 08, word writable files strike again. Check what the user was up to and use it to log in into flag 08 account. Okay, so su level 08. And we get a pcap file. Probably we're gonna need to smuggle this file to my attacker machine and analyze it with Wireshark. So we can do that. Let's go to my local machine, and here we're going to, so basically we're going to request the file from the Nebula machine. That's why we're gonna need to start a web server. So here python -m simple server. Okay, now my local machine, or we can just use the browser. Change the IP to 3, and as you can see, we get directory listing here. We download this file. I have already done this, so I'm going to go back to my machine, and here ls, this is the capture file. We're gonna analyze this with Wireshark. Okay, now to analyze the file correctly and extract the password, right click on the first packet, click on follow TCP stream, and here you can see, guys, this is the password. Now if you try this password, it's not going to work. So you will start looking for an alternative, right? What's going on here? Apparently this packet represents a capture of the user login process. As you can see, it is the user level 08 and the password. And probably there was a listener running on the machine that captured the login process. The data was exchanged or transferred in plain text. That's why we can see all the details clearly here. If we play with this here, show data as, and change the representation of the data from ASCII into hex. We'll scroll down, take a look at this. Now it starts here. This is the password. So back door, that's fine. And we have 3 dots. Now the hex representation here, it is 7F. Now 7F in ASCII, it is not dot, it is backspace, which means the user has typed back door and then they typed 3 times backspace. It means they have removed 3 characters. The 3 characters are R, O, O. So these are 3 characters. So here we now got 3 characters removed from the password. So now the password starts with B and ends with D. Let's go on 00RM8. And we have another backspace here, which means now the 8 is eliminated. And then we have ATE. Again, we have lastly a 0D, which is a carrier. We're going to leave this as is. So the password now is back, okay, D, and then we have 00RM and ATE. Now if we log in with this password, let's go back. Okay. So now su flag 08 back D00 uppercase R mates ID, and now we are get flag 08, execute get flag, and now we have solved this level. Up to the next level 09. There is a C setuid wrapper for some vulnerable PHP code. Okay, here it starts to get interesting. Okay, let's now log into 08, 09. Okay, now this is the wrapper. It has the SUID bit set. Means when we execute flag 09, it's going to execute as flag 09. And we have the PHP code. So it appears that the PHP code here, okay, needs to be supplied as an input to the wrapper. So the wrapper here executes with the PHP file as an input. Let's take a look at the PHP file. Probably this is a command injection. And we see this function. This function, if used with /e in PHP, it opens chances for PHP command execution, usually through the system function. So here, if we try to execute flag 09, we get these warnings. 2 notices and 1 warning. The warning says file get contents. File name cannot be empty. You go back here. This is the let's see, file get contents. Let's see where this function. Yeah, here it is. So here we need to supply the file name variable. The file name variable should include the PHP the PHP file. Here in our scenario, it should be the flag 09. So the flag 09, it should be supplied as an input to the wrapper here through this. Now the complete function here, name is markup. The markup takes two arguments. The first one is the file name, which we need to supply. In our scenario, it is flag 09. We're going to do that. And then it uses another argument, use underscore me, where there is, it's not clear what's the use of this in this code. And they are both called here. So the markup function is called using two system arguments. So we need to supply now two system arguments. One is for file name and the other one is for the use me. So probably file name is clear now. Use me is not clear. What is clear though is that the file name, okay, is again used without any input validation. So again, we're gonna conduct command injection, or we're going to execute system commands through the file name here. Probably we're going to supply a fake file here. So instead of supplying the expected file, which is flag09.php, we're going to create our own file and supply it. So let's now go to temp, and here we create our own file. Probably we're gonna create, you can create any file you want, as long as it does the correct job. So nano level 09 solution. So here I'm going to use email. I'm gonna explain why. So here I'm going to execute or use system, because here we are executing PHP functions through the wrapper. Okay, because again, first thing, there is no input validation on the file name, and there is preg replace. So preg replace here allows for the execution of PHP system functions. Among them is the system. So here system, and inside system I'm going to use the use me. Probably here what's gonna happen, the use me will be the command that we want to execute. Okay, file name is the file that will execute this command, which is what we're doing here. We're going to execute the command, which is use me, through the file name. The file name contains a PHP function system to do just that. So why email here? Because we need to conform to the expected input by the code. Here it is email, so we're gonna have to follow this formula. This is the formula, as you can see here, guys. And that's why I'm creating the file with such content. Okay, and now what we're going to do, we're gonna go back to home flag 09 and now execute flag 09, but I'm going to supply the file we created. The file here again contains PHP function, which is system, to execute the command that I'm going to supply instead of this argument. Let's try ls. And indeed, guys, we get directory listing of the files. Let's now try and get flag. And now it worked. We have solved this level. Level 010 is very noisy level. And it is based on something called time to check, time to use, which is a very rare vulnerability you might come across. You still might come across this vulnerability in legacy systems. I'm going to skip this level, guys, because it contains a lot of noise and you have to execute endless loops of bash scripts to get it solved. Level 11, again, also it has another problem in the code. I'm going to go now to level 12. In level 12, we have the description that says there is a backdoor process listening on port 50,001. 50,001, I guess, yeah. So su level 12, go to home flag 12. So we get a Lua file. which is the exact code here we got. It is a Lua code. We have user input sent as password. Now the function hash performs a hash on the password. It hashes the password and compares it to a hard-coded hash. This line. We see this io.popen. io.popen is the equivalent of OS execute in Python. So we have here a call to system commands that involves the user input represented by the password. There is no validation on the password. Again, here we are facing command injection. But to solve this challenge, we're going to have to do it differently this time. This time we're going to do it on my machine. So let's now close Wireshark. And here if you connect to NC 192.168.125.133 on port 50,001, connection refused. Probably gonna do it from here. Okay, NC 127.001 50,001 password. Alright, so here is the password that we will supply. The password here will be hashed. This is the user input. We're going to supply a formula for command injection. Now let's go back, see what we can do here. So the password is hashed and compared to a hard-coded hash. Other than that, let's see here. We want to see if there is a way to create a formula for the command injection so that the code doesn't crash, but probably there is no expected form for the user input. So we're going to improvise. Who am I? Try a simple command, and then we send it to home flag 12 test. So here we execute who am I, okay, and we send the output to test, and we wrap this here. Oh no, what happened? Okay, probably we're gonna have to do this one more time. Okay, better luck next time. Let's now check /home/flag12. Indeed, there is a file that was created, cat test, and it contains the output of the whoami command. So successful, we have conducted command injection. Next step is to, guys, we want to solve the challenge. So we're going to execute the get flag. We're going to connect again. Going to write it one more time like this. Get flag, send the output to home flag 12 test 2. Okay, cat test 2, and this solves this challenge. So now we have solved around 12 challenges.